Page 507, number 69. Write the partial fraction decomposition for the rational expression. And we have 5 minus x over 2x squared plus x minus 1. Well, to start these problems, what we need to do is factor this denominator here. And this can be factored as 2x times x and 1 times 1. And let's try negative 1 and plus 1. And if I use FOIL on this, I'll get 2x squared plus x minus 1. So I have factored correctly. Okay, once we have this factored, we need to rewrite this original fraction as some variable, let's just call it a, over the first of these factors, 2x minus 1, plus some variable, let's call it b, over the second of these factors, let's call it x plus 1. Okay, now we need to solve for a and b, and to do that, let's try to add these together. Now to add these, we're going to need a common denominator. Now the nice thing is we know the common denominator is right over here. So if I multiply the first fraction, top and bottom, by x plus 1, I'll have my common denominator. The second fraction, if I multiply the top and bottom by 2x minus 1, I'll have my common denominator. Okay, now once we have this common denominator, we can disregard it because we can just set the numerators equal to each other. They're all over the same value, so we can disregard the denominator. So let's rewrite what we have on top of this fraction. We have 5 minus x is equal to ax plus 1 times a plus 2bx minus 1 times b. Okay, now that we've done that, here's the tricky part. Let's look at just the x's. Over on the left-hand side of the equal sign, I have negative x. On the right-hand side, I have a times x plus 2b times x. So these two added together must be equal to this value, negative 1. So I can just look at the coefficients. I can say a plus 2b must be equal to negative 1. So let's write that. A plus 2b must be equal to negative 1. That's my x's. Now let's look at our numbers. Here I have a, here I have minus b, and here I have 5. So these two numeric values, a minus b, must be equal to this numeric value 5. So let's write that out. A minus b equals 5. Well, now that I have two equations, two variables, a and b, I can solve for a and b. Now I'm just going to change the signs of my bottom equations so that when I add these two together, the a's will cancel out. So I have 3b equals negative 6, which gives me b equals negative 2. Well, once I know b is negative 2, I can plug that into either equation. I'll just use this top equation here, which gives me a plus 2 times negative 2, or negative 4, equals negative 1. And if I add negative 4 to both sides, I get a equals 3. So, careful, my solution isn't the 0.3 comma negative 2. My solution is what I get when I plug a and b back in up here. So it's going to be 3 over 2x minus 1 plus negative 2, or I could say minus 2 over x plus 1. And there's my partial fraction decomposition of this original fraction. If I added these two together, I would get this original fraction.